Section 1.7 is on function notation, and that is just a way in which a function can be represented using symbols and signs. So the most frequently used function notation is f of x, which is read f of x. So it's an f with an x in parentheses. And f is the name of the function, and x is the variable used in the function. So if I had different letters, I could name a function g of x. I could name a function h of t. The letter inside of the parentheses is what variables being used in the equation. The letter outside, so the f, the g, the h, those are just different names. So just like you guys all have different names, functions can have different names as well. And when we have a function, normally you guys are used to seeing them as y equals 2x plus 3. That f of x is just the y. So it just replaces that y piece in the equation. And then that would be read f of x equals 2x plus 3. So for example 1, each function here we have to evaluate when x is 0, 1/2, and -2. So they just replace the x in function notation with what number we have to plug in. So if I plug in 0 here, I'm going to have f of 0 equal to 7 minus 2 times 0. And if I do 2 times 0, I get 0. So 7 minus 0 is 7. So f of 0 equals 7. Then I have to do the same thing with 1/2. So f of 1/2 is going to be 7 minus 2 times 1/2. Half of 2 is 1, so that's going to be 7 minus 1. So f of 1/2 would be 6. And then one more time with -2. So f of -2 is going to equal 7 minus 2 times -2. And the -2 times the -2 is a +4, so that would be 7 plus 4. So that would equal 11. So my 3 answers for part A would be 7, 6, and 11. Then if they give you a graph is actually a little bit easier because you just have to read the graph. So for the first one, f of 0. So our x value is 0, and that's right there at the origin on a graph. We just have to move up or down until we meet the graph that's being shown on the picture. So in this case, we have to go up. So if I go up, I meet that graph at 4. So f of 0, when x is 0, our y is 4. And then again for 1/2 would be right here on the x-axis. So we have to go up until we meet that graph. And it looks like when x is 1/2, our y value would be about 3.5. And then our last one is when x is -2 over here. So we have to go up until we meet. And when x is -2, our y value is +2. 2 more vocab words here. Dependent variable is the output or the f of x, the answer of the function, because it depends on what the input is. So if we put 2 in, we're going to get a different answer as if we put 5 in or -10 or whatever. So that answer depends on the input. So the dependent variable is our answer, our f of x, our y. Independent variable is the input, which is the x value of the function. So it's whatever we put into the function is our independent variable. Example 2, we want to graph each function. This diagram shows the maximum recommended heart rate for women by age. So we just have to put this information onto a graph. So looking at the x values, it goes from 0 to 40. So that would be pretty simple to just go by 10. So 10, 20, 30, and 40. But then going up, it looks like my lowest number is 181 and my largest is 209. So I definitely don't want to start my graph at 0. I want to start it more at maybe 180 and go up to 210. So I'm going to draw a little squiggly mark at the bottom showing that I'm skipping some numbers. And then I'm going to go by 10. So 180, 190, 200, 210. And then I'm going to plot these points on here. 0 is paired up with 209, so over 0 up 209, over 10 and up 202, over 20 and up 195, over 30 and up 188, and over 40 and up 181. And we're not going to connect the dots because we weren't given a function, we were just giving these particular points here. Then for part B, it says the maximum recommended heart rate H for men is a function of HA and can be calculated with H of A equals 214 minus point A times A. So heart rate was H and the age is our A. So we're going to have to start off by making a T-chart, and we're plugging in an A value and we're getting H of A for our answer. So we get to pick some numbers here. I'm going to pick the same numbers from up above. So 0, 10, 20, 30, and 40. So if I plug 0 in, I'm going to have 214 minus 0.8 times 0. So that would be 214 minus 0, which is 214. Then I'm going to plug 10 in. So I'm going to have 214 minus 0.8 times 10. Well, 0.8 times 10 would be 8. So 214 minus 8 would be 206. And then plug 20 in. 214 minus 0.8 times 20 would give us 98. And then 214 minus 0.8 times 30 would give us 190. And 214 minus 0.8 times 40 would give us 182. And we are going to have to show that on a graph as well because the directions said to graph each function. So I am going to make my x-axis, again, 0 to 40, so go by tens. And then my y values or my answers start at 182, so I probably want to start about 180 again, but I have to go up to 214, which maybe I want to go up to 215 or 220 if I'm going by tens. So 180, 190, 200, 210, 220. And I'm going to plot my points. I have to go over 0 and up 214, over 10 and up 206, over 20 and up 198, and over 30 and up 190, over 40 and up 182. So comparing those two, it looks like women's heart rates are just a little bit higher. All right, last example here. The Japanese bullet train that travels from Tokyo to Kyoto averages about 156 kilometers per hour. The distance from Tokyo to Kyoto is 380 kilometers. Part A wants us to write a function to represent the distance remaining on the trip after a certain amount of time. So our answer is going to be the distance remaining. Oops, I do not want to keep it that. So the distance remaining is our answer, is going to equal our total distance that we have to travel and then minus the distance we've already traveled. So Our distance remaining, we could call f of x. The total traveled, the total distance we have to travel is 380 kilometers. And then we're going to take off what we've already traveled, which would be 156 per hour. So each hour we can go 156. So that would be our function notation, except for I made one mistake. I called it x in the f of x, but I called it h over here. So those variables definitely have to match. So I'm going to change that one to an h. Okay, so that is our formula, or our function that we have to use. And then part B says, what is the value of the function for an input of 1.5 and what does it represent? So we're going to plug in 1.5 for h. So we're going to have f of 1.5 equals 380 minus 156 times 1.5. And when I get that, when I plug that all into my calculator, I'm going to get f of 1.5 is going to equal 146. So the 1.5, plugging that in, means that I've been traveling for an hour and a half. So 1.5 hours. And the 146 that I got for an answer is the distance remaining. So 146 kilometers remaining in the trip. So if you go back up here and look, I wrote it out in words here. The distance remaining equals this total travel, our distance minus what we've already gone. So the distance remaining is our answer. We got 146 for our answer, so that's how many kilometers are remaining in this trip.